In this video, we're going to talk about the home screen of the simulation software. So when you install your MTS simulation software, a few icons are going to appear on your desktop. The icon that takes us into the CNC simulation software is going to look like this guy, a blue MTS square. It will say MTS Top Start. So a double click on that will open up what I call the home screen of our software. From this home screen, we can go to the different options that are available. Across the top, you'll notice some major icons. Top turn is going to take us into the turning section. You'll find your lathes, your mill turn machines inside of top turn. The next one, when we click on it, top mill, will contain all your milling machines, your verticals, your horizontals, the robots, water jets, wood routers, and things like that if you have those options. If you have the cam options, then 2D or 3D cam will show up. We'll get into those in later videos. And then top train takes us into the e-learning piece of the MTS software, and we'll get into that in a later video as well. So we select which thing we want to do. For our purposes today, we're going to select top mill so that we're in the milling piece. Below that, you see the drop down that selects the machine and controller. When I click on the arrow down, it shows me all my options for machine and controller. Depending on your installation of software, you may have a lot of machines and controllers like I have here. You may just have a few. You can see the machines are paired with multiple controllers. So unlike in the real world, you buy a machine, maybe you buy this DMU50, the machine will come with an actual controller. We can pair multiple controllers with the actual machine. So you may have, here as we see, a DMU50, and we can put a PAL, a Heidenheim, a Cinemeric, whatever type of controller we want, we can drive that machine with virtually. If you prefer to see them listed not by machine and then controller, but by controller instead, that's very easy. On the mode button, we select sort by controls, and now when we see the drop down, we have it sorted by controls. Here we see the PAL controller. PAL is a neutral programming language, very popular outside the United States. It's a global standard for CNC programming. Many of the apprentice and schools and teaching going on outside of the US is done in the PAL language. And now we have all of the machines, all of the mills in this instance that are listed, that are mated with a PAL controller listed here. So if I know, for instance, I want to work with a FANUC controller, I can scroll to my FANUC controllers and then find the machine that I'm looking for. In this case, let's see, OI Mate MTAD compact drill. I can select that machine with the FANUC controller on that machine. So I'm going to go back to sorting by machines. I'm going to click my drop down, and I'm going to go find the Haas VF2. Fortunately, they're in alphabetical order. Haas VF2SS with a UTC controller. Now, the UTC controller, we call it the Universal Training Controller. And that controller is based off from the FANUC language. So if you know UTC, you know FANUC. FANUC, however, doesn't have some of the different options that other languages have, such as pocketing routines, circular and odd-shaped pocketing routines, and some of the other routines that the Siemens-based controllers and so forth have. So the UTC is a good neutral controller to program in, and it gives you a lot of options that you wouldn't have in just one specific programming language. Or if you're an industry user, you have a Haas machine on your shop floor and you want to work in the Haas language, then select the Haas controller. After I've selected the machine, I notice that there's some information about that machine on the page. If I select information, then it shows me, well, it's a milling machine, we know that, but it's also a 3-axis machine. It has X, Y, and Z axis. It has 24 positions, and it's an SK40, or we may commonly call that a CAT 40 machine. Remember that in the simulation software, there may be different types of interface or different types of tool norm. We can put a Capto spindle on a machine. We can put a BT spindle on a machine, a VDI spindle. So there are different options for spindle. So make sure that you have the machine and the spindle combination that you're looking for. if you've created a unique tool or tooling combination inside of the CAT 40 or SK 40 tool norm, and you select a machine that's, for instance, a BT machine, you may not find that tool because it's not in that tool norm. It's not in that library of tools. If I select the drop down so that the drop down is now the active thing, and I use my arrow up or arrow down keys on my keyboard, I can now scroll through the different machine and controller combinations. So if it's a little bit difficult for me to look at all those words and all that text, if I just want to scroll through and look at the different machine combinations, then I can just use my arrow key to do that, to show me those different machine combinations. And when I see the one that I'm looking for, I can select that one. Here on this particular machine, we see it's telling us it has X, Y, Z, A, and C axis. So this is a 5-axis machine. It has 40 positions, and it's capable of accepting multiple tool norms in its spindle: CAT 40, 50, HSK 63, and HSK 100. So this is a pretty versatile machine. So we're going to go back to our Haas controlled machine again. Select our UTC 3-axis Haas machine. And now I'm going to select the Programs tab. And when I select the Programs tab, that shows me the programs that have been simulated inside of this machine. So here we've got several programs. If I wanted to go and simulate the MTS mill part, I would just select that MTS mill part, and now I can do different things with it. I like to caution people about double clicking. You can double click this. If I double click it, it takes me directly into the simulation environment. And now I'm in the simulation environment simulating that program. But in a lot of cases, not only in the MTS software, but in other softwares, double clicking where a single click is required will do the thing that you intend to do and then click on something behind it and get you in trouble in time. So I always caution people, if it's a double click activity, double click it. But if it's not, I like to select the program and then select simulator if I want to go into the simulation environment. A lot of us are double clickers, and sometimes that's not necessarily a good thing. There's a couple of folders that you see here. Inside the NC Programs folder are the programs that we've already simulated. They're set up and ready to go for simulation. If I want to go into the simulation environment with just a blank simulation with no program up and running, no program to simulate, I just highlight the NC Programs folder and then click Simulator. And then when I'm in my simulation environment, it goes right to the home screen. If I look at my editor, I have no program. It's just a blank simulation. There's nothing to actually be simulated there. I can start from there if I'm writing a program or whatever I choose to do from there. The other folder is a template folder. In the template folder, we can set up templates that we can start programs from. So if, for instance, you have a magazine of tools that you like to use on your milling machine, it contains a face mill, a 1/2-inch end mill, whatever your magazine of choice is, you can create that magazine. If there's certain work holding that you want to start with, you can create that, save it as a template. And then when we create a new simulation, we can start from that template, and we already have our magazine, our work holding, and that sort of thing set, and we don't have to redo work. It aids in getting us up and simulating quicker. The NC Print folder contains NC Print items that we've already made. So if I select one of the files that's inside of the NC Print folder, you see I only have the NC Print option. I can go into NC Print, and then I can work with my NC Print file that I've created. NC Print is a way for us to create tests or exercises from simulated programs. Here you can see we've already grayed out the T, for instance. Now I'm making a test or an exercise that students have to look at the simulation, look at the information, and answer the questions that we've created within NC Print. We'll explore NC Print further in another video. So I'm going to select my MTS mill part hex, and you see I have a lot of options here on the right hand side. We've already looked at Simulator, and Simulator will take us into the simulation environment. NC Edit, if we don't want to simulate the program, we just want to work within this MTS editor, I can select NC Edit, and that takes my program right into the editor. Now I can edit, work on my program. It's got all the function of our MTS editor, conditional formatting for color of words, explanation of the codes that we find in the different lines of code. So the NC Edit button will take us right into the editor. We're not in the simulation environment. We're just seeing the program in an editor. The post processor, it's very powerful. Those of us that know CAM recognize the word post processor. We know when we create toolpaths in CAM, in order to actually turn it into the proper G code to run on our CNC machines, we have to post process it. And the post processor basically is a translator that turns it from the CAM language into the CNC language. The post processor in the MTS software is the same, but a little bit different in that the post processor allows us to take one controller language and translate it into another. So if I've programmed my machine in the UTC language, the universal language, and I want to run it on an actual Haas machine, on an actual Mazak, on an actual Fanuc machine, whatever the case may be, I can translate it from one language to another. If I have a program that was written in the Siemens language, one of the Siemens language, and we want to run it on a Fanuc machine, we can post-process it or translate it into the language of the machine that we want. Transmission, if I want to remember the days of DNC, if I want to transmit that program and put it directly onto my CNC machine, within our simulation software, we have the ability to do that. We can set the port baud rate, parity, things like that, in order to communicate directly with our controller and place the program directly onto our CNC machine without the need to go into a different piece of software to do that. NC Setup takes us into the setup of the simulation environment. So again, I select the program and I select NC Setup, and now there we go. Now I'm in the NC Setup portion. I can put my front end information. I can select my work holding, my part, the clamping. Zero Register will explore all the options of setting up the NC machine in the simulation environment, again in another video. But we can go directly there from the home page. We talked about NC Print already, but NC Print button will take us into the NC Print environment. And then Top Cam 3D will take us into our 3D CAM environment, a fully associative programming software that allows us to create complex CNC programs from our models. So again, if I want to go into the simulation, I select my MTS Millpart Hex, I select Simulator, and if I go into my simulation environment. In the next video, we'll talk about the options here inside of this MTS simulation environment and all the different things we can do with the simulator. I hope this was helpful. Thank you for your time.